Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic PPM, Pulse Position Modulation. So what is this pulse position modulation? So pulse position modulation is a modulation technique in which the position of the pulses varies according to the amplitude of the modulating signal. The width of the pulses remains constant only there will be a change in the position of the pulses. The width of the pulses remains constant. Hence, the transmitted power remains same. First, generation of this pulse position modulated signal. So the diagram, the block diagram, first a PAM, pulse amplitude signal is generated. Pulse amplitude modulated signal is generated, which is processed at the comparator to generate this pulse width modulated signal, PWM. So after processing, the output of the comparator is fed as an input to the monostable multivibrator. So being a negative edge triggered, the output of the vibrator goes high with the trailing edge of the pulse width modulated signal. So trailing edge of this pulse width modulation shifts with the modulating signal, creating a pulse position modulated pulses. And next is a detection of this pulse position modulated signal. So detecting the original message signal from the PPM signal. So first a PAM signal is produced which is processed at the comparator to generate this pulse width modulated signal. So after processing, it will be given to the comparator as an input to the monostable multivibrator. It is being negative edge triggered, the output of the vibrator goes high with the trailing edge of the PWM signal. The trailing edge of this PWM shifts with the modulating signal, creating this PPM pulses. And next is what are all the advantages of this pulse position modulation? So due to constant width of the pulses, the transmission power remains constant and it displays no variations. PPM shows a better noise quality as compared to an amplitude modulated signal. This is because the information in PPM is stored in position rather than amplitude. The recovery process of this PPM signal from its distorted form is very easy and it is very simple. The PPM system has a very low system requirement, so it is frequently used in lightweight applications like simple accessories. The overall power required for such a system is low as compared to PAM, making it more power efficient modulation technique. And next is drawbacks of this pulse position modulation. The major limitation of this technique is that it requires larger bandwidth as compared to other methods, increasing the bandwidth consumption. And in order to perform a detection of the signal at the receiver, it is necessary that transmitter and the receiver have to be synchronized. This is not possible every time. In case of this pulse width modulation, there is no need for synchronization of transmitter and receiver. Whereas in case of pulse position modulation, both the transmitter and the receiver have to be synchronized for proper reduction of the original signal from the pulse position modulated signal. This is not possible every time. It is really sensitive to phenomena like interference, which can disturb the transmission by changing the differences in arrivals of each and every signal. So which results in the interference process. And next one is the applications of the pulse with pulse position modulation. This modulation technique finds its application in air traffic control system, in radio control and in military applications. Since pulse position modulation is used in non-coherent detection when we don't require receiver having a phase lock loop for tracking the carrier phase. Since this modulation technique helps in compression of data, it is often used for storage purposes. We can employ this pulse position modulation in optimal communication. This is done to minimize the dispersion effect and efficiently use the laser power. Pulse position modulation is employed in remote control systems in which a stream of pulses is used to encode the information in bits. And the assessment is that what is this pulse position modulation and what are all the applications of the pulse position modulation. So that's all about the introduction to pulse position modulation and how this pulse position modulated signal is being generated. We have seen this modulation circuit, and we have seen how this message signal is being get extracted from the pulse position modulated signal. So we have seen this demodulated circuit, and also we have seen what are all the advantages of this pulse position modulation and what are all the drawbacks of the pulse position modulation and what are all the applications of the pulse position modulation. The main drawback of this pulse position modulation is that it requires a synchronization of a transmitter and the receiver. So that's all about this pulse position modulation. Thank you.